Would you rather have one factory that knows how to create 50 computers with one call of a method, or 50 methods that each know how to make one type of computer? Obviously, you would rather have one. The factory pattern is one of the most widely used patterns in software design today. Software design patterns are well-defined patterns that we as developers use. They approach a problem and provide a concise, readable solution for how to solve them. By learning them, you can become a more well-versed and more marketable programmer. Today, we're going to talk about the factory pattern and how we can apply it in JavaScript. Imagine you have a factory that creates computers. All computers are the same in essence. They have a case, they have memory, they have CPU, etc. The internal pieces, whether the CPU is Intel or AMD, the GPU is NVIDIA or AMD, do not matter when we use a factory pattern. We can model that in software by first creating an interface that all of our computer objects will inherit from. Inside of the interface, we will define some basic properties like CPU, GPU, memory, and gigs, and this will serve as the basis of commonality for our factory object. We can then create a computer factory that will create the computers in a generic way by passing in the string, which is the computer type, and the object for the attributes. And what this will look like in the code is inside of this create computer method, we'll have some kind of switch statement that actually creates these specific MacBook Air, MacBook Pro, or MacBook Mini computer objects. And if we take a look below at these implemented objects that implement from a computer, we can see they all have the 3 shared common values. This is what's important when you actually have a factory pattern. So now that we have the code open, let's actually talk about how we can make some of these objects that implement this interface. Interfaces do not exist in JavaScript. So we actually need to create objects that share a common set of properties, and we can do that by creating constructor functions. So the first one we're going to create is the MacBook Mini. We're going to say const MacBook Mini equals a function. This is the constructor function. It's going to take in those properties that we spoke about before. So these are our CPU, GPU, and memory and gigs. And from here, we can actually make a function, and we can say this.cpu equals CPU, or we can default it to 0, whatever value we're going to use. This.gpu equals GPU, or 0. And the same thing, we can say this.memory and gigs equals memory and gigs, or 0. This is our first object that our factory is actually able to create. But it wouldn't be very useful if we could only create one object. So let's talk about how we can make many objects. We can actually do the same thing we did here, but let's make a MacBook Pro. Const MacBook Pro equals this constructor function. Remember, it's the CPU, the GPU, and the memory and gigs. And then we're going to do the same thing that we did before. This.cpu equals the CPU, or 0. This.gpu equals the GPU, or 0. And this.the memory and gigs equals the memory and gigs, or 0. We're going to export this. And now we have 2 objects that actually implement this generic interface. For the sake of time, I'm not going to create the third object because I think the point is here. But now we can actually create the factory. So the first thing we can do is we can actually import these MacBook Mini and the MacBook Pro attributes as a dependency. And we can create this gadget object, or this laptop or computer object. So we can create this computer object. We can pass in these 2 values, and this will make it really easy to key off them later. And so we could export this object that contains this create computer method, and it takes a type and the attributes you want to pass in to the factory. So we can say const computer equals computer. We should probably actually do computer type equals computer, and we can pass in this type value, and we can say return new computer type and pass in these attributes. And now what we've created here is a computer factory that's able to create any computer that we've actually implemented below. So what would happen if we actually tried to pass in a value that wasn't in the factory? Because that's an important case with factories. We probably need to make sure if it's not existing inside the object, we don't actually try to grab it. We can do if type in computer, but we actually want to make this not type in computer. We can throw a new error, and we can say type does not exist inside the factory. And this will cover the error cases for if it doesn't exist inside the factory as an object. We don't want to actually pass back null or something. That probably wouldn't be a very good pattern to follow. We want to actually throw an error. So it wouldn't be meaningful to actually implement the factory pattern without showing how we can use it. So I've actually required it as a dependency up here, and you can see that. And then below, I actually created 2 computers. So the first thing I did was I called the laptop factory create computer. I passed in MacBook Pro as a parameter, and I passed these 3 objects in, or these 3 properties in, to actually create the computer. An Intel CPU, NVIDIA GPU, and some memory. But say I want to create a completely separate computer object. I called it again with MacBook Mini, and I passed in AMD and NVIDIA, and then I passed in some different memory. And then we can actually console log to see the result. So I console.log this after I run it, and you can see I created a MacBook Mini, and I also created a MacBook Pro. They all have different properties, and this is exactly what we expected. And this is the power of the factory pattern. You can actually create objects in a concise way using the same method as long as everything implements the same interface. And instead of having 50 different pieces of logic that actually create different objects that are the same, you can have one that actually creates the objects for you. This can be useful across many use cases. You might have a sound object. You might, be able to create headphones. You might be able to create speakers. You might have a connection object that might take Bluetooth or Wi-Fi or something like that. There are so many different use cases for the factory pattern, and that's why it's such a widely used pattern, and especially in object-oriented language like Java and C#. If you guys like this kind of content and you like this video, please consider subscribing and liking this video, and I'll see you guys another day. Thank you.